Uh, Good afternoon, Ayyappan.
Yeah, good afternoon.
Thank you, Ayyappan. How are you?
Fine, fine.
Thank you very much. Thank you very much. Dear students and faculty members of Mechanical Engineering Department, welcome you all for today's webinar. So let me introduce Mr. Ayyappan. So Mr. Ayyappan is my classmate in the undergraduation. Ayyappan sir is Ayyappan presently working in the Heidelberg Materials Group as maintenance expert in Indonesia. So Ayyappan's most of the experiences is on the maintenance field. So Ayyappan, let me give a brief about the activity. So in our mechanical engineering department curriculum, we used to cover almost all technology-oriented things, but we don't have subjects input on maintenance aspect. So we thought of giving some input on maintenance aspect. Also, we want to use the students to involve in the small kind of maintenance activity in our department, like routine maintenance of machineries and equipment. So we thought of starting a club called a maintenance activity club. So in that, we planning to give some maintenance-oriented guest lectures and visits to students, and also involve them in field work like maintenance of equipment in our laboratories and that. So that is how it is started. We initiated the club in the month of September, but now only we able to initiate the activity. So this is going to be the first program. So we call it as the inaugural lecture of the maintenance activity club. Dear students, here we have with us Mr. Ayyappan THIAGARAJAN from Heidelberg Materials Group, Indonesia. He is a maintenance expert. He is involved in maintenance management, preventive, predictive, and reliability-centered maintenance of various systems. And he is also experienced in the technical services, troubleshooting, and the reliability improvements, maintenance audit, shutdown management, and technical training delivery. And he has also got exposure and experience in advanced predictive maintenance implementation, focusing on downtime reduction, process improvement, deep bottlenecking, and quality and improvement in maintenance system. So when we approached through our network, Mr. Ayyappan readily accepted our invitation to deliver a session. That is actually, it's a very basic session. I thought I informed Mr. Ayyappan to give some basics about what is maintenance, what are the types of maintenance, how routine maintenance can be carried like that. So even though he is having a very vast experience in the maintenance field, what he is planning to deliver with our students today is very basic thing about maintenance. On behalf of Murugappa College and on behalf of the Department of Mechanical Engineering, and on behalf of all our students, I am having great pleasure in welcoming Mr. Ayyappan, and I am very thankful to you, Mr. Ayyappan, for readily accepting our invitation. Thank you. Now you can proceed according to your plan, Mr. Ayyappan. Thank you.
Okay, thank you. Thank you very much, Shekhar. And good afternoon to all of you and all other faculty members in this call and my dear students. So thank you for this college to giving me this opportunity and inviting me to give this inaugural lecture for this mechanical engineering activity club. So yeah, as Shekhar said, we will start with the basics of maintenance. That was our today's target to have. So basically, yeah, I'm a mechanical engineer, and yeah, I studied the undergraduation together with your Mr. Shekhar. So I'm happy to see him after a long time too on this call. So okay, directly we will jump to the presentation. So let me share my screen, right? Yeah.
Yeah, it's visible, but you have to go to presentation mode.
Yeah. Sure.
Thank you.
You are able to see in presentation mode or no?
Not it came to presentation mode. It's in slide mode only.
Still not yet, huh?
Yes.
Let me share the other way. Yeah. Hope it is visible now.
No, it's not it. Actually, the previous method is correct. I think you have to go to slideshow mode. That's all. Previous is the go to slideshow in the top menu.
I have used that, but I don't know. It is not changing.
Okay.
Is it okay now or not yet?
No, it's not it. Maybe I think it's taking some time.
Yeah.
You can just, or otherwise you can just proceed with this.
Is it okay now?
No.
No.
Okay. Not one. I think you shared your entire screen, I think. Maybe you might be used to Zoom mostly.
No, we use actually Teams.
Teams, that is in the sharing, they will ask for some entire screen and something. Let me know. Share, there are 3 options. Is there, no?
Yeah.
I think you can go to entire screen and go to presentation.
Yeah, now I did this.
Yeah, it's okay. It's okay now. It's okay.
Okay now? Yeah. Okay. Okay, right. Okay, let's start with this. So today's agenda is we will talk about the maintenance philosophy and strategy. So to start with, we talk about the philosophy, like what kind of maintenance we adopt in any industry. And also we talk about the strategies, which one will work better for what kind of equipments we have in the plant and what kind of maintenance strategy we would plan to have excellence in the system. And also we see slightly about the organization, maintenance organization, which will well fit for different kinds of industries. Then we will also see about root cause failure analysis and FMEA, this failure mode and effects analysis, which are together as a reliability tool used for improving the maintenance systems. And in this digitalization era, so we have so many advancement in technologies, so that has also impacted the maintenance systems. So we have this advanced predictive maintenance systems. So I'll continue with the presentation. So in case of any questions, I request our students to keep it, and then at the end, I will answer all your questions. So what is maintenance? So basically, maintenance is to upkeep the healthy condition of the any machinery or rotating equipment, or for that matter, any equipment. So this is broadly divided into three categories. Inspection, to know what is the actual state of that equipment or machinery. And then service is to maintain some parts, replace some small parts or repair something or do some lubrication is also kind of service to keep the healthy condition. And after a certain period of time, we might have to do a major replacement or a shutdown to bring or renew the lifetime of that equipment, to enhance the lifetime. So in maintenance in general is inspection, service and repairs. So how it is done? So for example, if you have any equipment in the industry, then first thing is after operating it for some time, we need to inspect it. There are two kinds of inspections. One is online, offline. During working of the machinery also we can measure some parameters, and sometimes we take the machine to a shut-off condition and then do measure some parameters, do some inspections. We will cover those details in the later slides. So this forms the part of inspection. Then after inspection, we find some deviation or abnormalities. Then we have to plan for the correction. So planning is the first step. And in planning includes manpower planning, the resources, as well as the spare parts, then the timeline, when we will do that job. So this is the planning task. Then third comes the real execution. We execute that planned activities. So why we say put a arrow mark back and forth is all these three activities, three functions are interrelated. That means it cannot be working on a compartmental modes. One has to be connected with others. So the engineers who are assigned with the planning task have to be coordinating with the inspectors as well as the execution engineers. So maintenance is always said to be in a triangle covering broadly these three functions. So here are some photographs showing the pinion driving a gear, a big rotary shell or a dryer. So that picture on the right hand side, top one, is showing a good surface, a teeth surface. The bottom one has a lot of pitting, scurvy, or it is having a rough surface, which is not a desired one. So why does it happen? Why do this breakdown occurs? Think it. Then this is some roller mills which has got a very big bearings of diameter more than 1.5 meter diameters. You see on the right side the rollers were broken. Why do such a big bearings fail? Then we have got some kiln rotating tires which have got a crack during operation. So why does a tire should crack? So there are several things which may come up in your mind. Here for some bearings, we see the grease is contaminated. ID fan, its induced draft fan is a very common equipment used in all the process industries. So if you use a contaminated grease, the bearing could fail, or the contamination could happen from dust. So this picture shows a bearing without adequate lubricant. There is no sufficient lubrication. So what does it mean? Poor housekeeping also leads to equipment failures. So when you think about why does this breakdowns occur, then we get an answer. There are four broad categories. Why do such a machineries which are well designed for a certain lifetime, why does it fail? First one is about design and manufacturing of equipment. So, okay, many times the problem could happen due to a poor design or even during the lack of quality control during manufacturing of the equipment, it could fail, like what we have seen in the previous few photographs. Or if you are operating the equipment to a limit which is beyond it is designed for, basically you are overloading the equipment, you are operating beyond the factor of safety, then also it could fail. But today's agenda is not about these first two things. We are not going to discuss much about design and operating limits. We focus clearly on maintenance. Breakdowns, machine breakdowns occur based on statistics. More than 60% of the cases are related to maintenance. So the other two categories broadly is about less than 40%. So mainly maintenance or lack of adequate maintenance leads to more than 60% of the equipment failures in any plant or industry. Housekeeping is also considered to be a part of maintenance. So these two categories at the bottom severely influence the equipment breakdowns, which we have seen in the previous slides. So when we now talk about maintaining these equipments without this kind of failures, then we talk about our strategy. So what we should do if you are, for example, after you finish your studies, if you enter into an industry, you are a maintenance engineer, and what kind of maintenance system or strategy you would adopt for better operating your plant. There are 4 different categories: reactive maintenance, preventive maintenance, predictive or condition-based, and proactive. I have put the generation numbers as well there from 1 to 4, which will clearly indicate that 1 is a very old one. Reactive maintenance is not recommended at all for any kind of things. Why? So we see in the subsequent slides. So if you see, as the name itself is suggesting, reactive means you have a machine, you run it until it fails. You don't even bother to go and see or do some inspection or anything. So it's a firefighting approach. One day the machine fails, then give you a call, then you go and repair it, replace the parts which are broken or which are worn out. So here I have put also the advantages and disadvantages. Advantages could be less cost on short term, but if you consider the lifetime of the plant or lifetime of the equipment, then it may land up with huge cost as well. Staff, you don't need a maintenance staffing for this, but there are several disadvantages due to having unplanned stoppages. When you talk about maintenance, you should be very clear about planned stoppage and unplanned stoppage. Planned stoppage means we stop the plant or any equipment to do a maintenance or repair or any kind of service. This is basically not counted as a breakdown or a failure. We have a certain planning when the market demand is less, or when we have a sufficient storage in the warehouse, then we stop the plant for maintenance. Mostly we focus on unplanned stoppages, which are termed to be breakdowns. So if you follow this reactive maintenance strategy, you will end up with unplanned stoppages when your market demand is in a high peak season. Labor costs may increase because the breakdowns may happen anytime and you may have to attend to it immediately. So you cannot plan the workforce. Repair and replacement costs would be higher because you would not know what component of that machine will fail. So it will be a surprise. So after that, you may have to purchase that part if you don't have it readily in your inventory. Possibly secondary damage, that is called a subsequential damage. If you talk about, for example, a big gearbox, if one of the gear in the input stage is failing, and if a part or piece of that is falling to the next stage or next elsewhere, some to the bottom bearing level, then it could damage the whole gearbox. So the damage could be severe. In general, the plant staff would get demotivated with this kind of approach. So reactive maintenance is never ever recommended in these days. It was a very olden day structure. Why I bring it up here is you should know the generation, how it has transformed. So most of the plants or industry have started following this preventive maintenance for several decades now. Preventive maintenance means we do some inspections in a preventive way. We stop the equipment in a planned timeline, and then we check the condition of the equipment. I have got some examples. I will show it later. So we check the equipment for certain condition. Then if If we have to be changed, then we replace those parts time to time. We schedule it. For example, if there is some equipment which needs an inspection every month, then every month we stop it for 8 hours, probably in a day where we don't have a big market season or it is not affecting your business plan, then we do a repair. So this has got certain advantages over reactive maintenance, and you can definitely reduce your unplanned downtime because the equipment will not give you any surprises. It will definitely give you an early indication what kind of failure it is going to come in next few months or next year or in next few days. So you can plan your repair accordingly. So preventive maintenance is what a much better option than a reactive one. There are certain disadvantages as well here. This is every time when you stop the machine for inspection, you cannot dismantle it completely and do the maintenance and then put it back due to certain reasons, like either time constraint or resource constraint. You will not be able to do all of them every time. So still there is a chance that some failure could happen. Again, for doing this, you need plenty of resources to perform this preventive maintenance. Sometimes it may result in overdoing the maintenance as well. You stop on a regular basis, you inspect, but you find nothing. Maybe the equipment condition is still good. So this may result in some maintenance actions carried out, although it may not be needed. So here, this picture shows on the left side where you have got issues. The different issues are put it in different color to show that the issue in the red color is highly critical. Okay, the other ones has a less criticality. On the right side, if you see, you have got a cost. If you want to maintain any equipment, basically there are three types of costs. One is the maintenance manpower cost, the personal cost, the material cost, the spare parts and tools and tackles, whatever is needed. And then you need a contractors to do the service. So this is how you have to think about the strategy to balance it. If you are thinking of removing all the issues at a time, then it may land up in higher cost. So there comes a budgeting, maintenance budgeting, which is altogether a different subject. So if you want to optimize your maintenance budget, then you try to attend to the issue which is highly critical. For example, if the issue will damage the equipment or it will stop your production of the plant, then you may have to attend to that highly critical issue at the first instant and then control the cost. We may postpone certain non-critical issues to a later date. So this is how we have to balance between the available manpower as well as the cost budgeting. So this is the strategy is adopted in many industries to implement this system. So here I have put how a real-time preventive maintenance sheet works. Probably you might have heard or known about these fans. Any fans, if you look at it, it will have a impeller and two bearings on either sides, simply supported with the bearing housings, and a motor driving with the coupled on. So if you look at the left side, there are certain activities listed. Check and report any air leakage from shaft seal. And then there are certain checkpoints listed with the frequency. 1W means every week you need to check. 4W is every month you need to check. 26 maybe every half a year. So for any equipment or for all the equipment available in your industry, you prepare a master list like this, and then based on OEM recommendation, original equipment manufacturer also recommends certain frequency, what to check at what time and what to be replaced. So you first define this master schedule and then later on implement this in your regular maintenance activity. You keep checking this equipment on this designed frequency, then record the data and do the replacements as necessary. So this is what about preventive maintenance is. So you don't allow it to fail. So you have a intervention time to time. These frequencies are not hard and fast. You can adjust it based on your equipment performance or depending on the type of equipment and usage of the equipment. You can vary it. For example, if some of the activities every week you go and check, or the inspection team go and check, they don't find any abnormality, then after 6 months or 1 year, you can change it to become 2W or 4W, so that you can increase the frequency based on your experience from that equipment. So all equipment doesn't behave in the same fashion, even though if a fan is employed in an industry, in several places of the industry, one fan might perform differently than the other due to the type of gases it is handling or due to several other parameters. So this is giving in general, I think, a broad idea how a preventive maintenance works. Olden days, this master schedule were prepared in Excel sheets and people used to follow this. But nowadays there are so many computerized management systems are available. So you can punch in all these schedules, then you get an automatic work orders generated from that application. Then you just run through it. I have got some example screenshot as well, which we can see at later stage for those work order process flow. So this is about preventive maintenance. Then we jump to predictive maintenance. This is the next third generation, or we call. So preventive maintenance, yes, it covers, you can say 70–80% of our requirement to reach the level of a good maintenance system, but still it has got some problems. So to address that, this predictive maintenance has come, and more so is how to predict the actual condition of the component by avoiding a potential failure. So how to do, if any equipment is prone for wear and tear or corrosion related, then you start measuring the corrosion parameters, thickness. For example, if due to corrosion, if you are losing thickness on any structural member or steel member, then you start measuring the thickness. Then you will come to know, you can predict well in advance, okay, after so many years, this design, the thickness will come below the design level. So then, okay, we might have to change this component, otherwise it may fail. So we can predict the failure using certain measurement, real-time measurement of the equipment conditions. Nowadays, so many technologies and sensors are available to measure this. Ultrasonic thickness measurement is a one, probably you might have be using it in your laboratories or somewhere else, you might have seen that. So there are so many equipments available, sensors and tools available to support this maintenance practice. So this can be used. Advantage is you can predict the equipment failure time or the lifetime. Then you can easily convert that downtime into a planned maintenance. You can increase the lifetime of the equipment. Earlier in the preventive maintenance one, you will have, okay, for example, if you write here, at the end of, say, every 4 years, I'll change the impeller, the rotating impeller. That means without even considering the condition of the impeller, every 4 years, you replace it with a new one so that you don't have a failure or a surprise. But in this case, you don't go by such a time-based replacements. We go with the condition-based replacement. So how do you do that? You measure the thickness of the impeller blade or the shaft, and then you decide, okay, if it is still within the limit, then you continue to operate for another 2 years or another 3 years. So this definitely results in a less maintenance cost compared to reactive and preventive maintenance. So thereby there will be a cost savings as well. There are some disadvantages, not disadvantages, it is something which I have to say here. In order to deploy this kind of predictive maintenance, you might have to spend some money investment upfront for purchasing the sensors, implementing these tools, measurement systems, and also the maintenance engineer and the team has to be given a proper training how to use this tool and then use the analytical platform available in the tool to come to a decision-making process. So this is about predictive maintenance. Then last is proactive maintenance system. So this is what we call about root cause failure analysis and FMEA. So this mainly focuses on the maintenance management system. Now, so far we are talking about deploying certain strategy. Now you are having a overall view how to make a maintenance system. So for this, we need to develop the reliability-centered maintenance management process within the organization. So with this, we can attain the maintenance excellence. So when you go back to this condition-based maintenance, what are all the tools you can utilize? One is topmost one is vibration analysis, mainly used for gearbox, fans, any rotating equipments. You can use this vibration analysis tool. You can measure the vibrations when the plant is functioning or when the equipment is working. And then you can, first step is to collect the data. Then you prepare the analysis of the data, then interpret the results. Then you make a conclusion. What kind of action I would take if the vibration is high. Vibration analysis is a very interesting subject, but it's a very lengthy subject as well. So if you talk about any rotating equipment, then you have different frequencies and spectra. 1 into RPM, 2 into RPM, like that. So 1 into RPM always says about unbalance in your rotating equipment. So, and 2 into RPM talks about the mechanical looseness or alignment disturbances. And you measure vibrations in 3 directions: axial, vertical, and horizontal. So horizontal vibrations mean something. If your axial vibration is high in the axial direction, it means something else. So this kind of tools, plenty of tools are available in the market, in the industry. So you can utilize these tools to predict the condition of your rotating equipment. Then comes the lubrication, monitoring and analysis. So we have certain, what do you call, if you have a big gearbox, say for example, filled with 5 kl or 7 kl of oil, you cannot change such a big quantity of oil so frequently. It will be a time consuming and it will be expensive task. So what we do is we take out some samples and then we test it in a laboratory and see the condition of the oil. And then we look also for some iron, ferrous particle, non-ferrous particles in that analysis. Then we decide, okay, the oil condition, not only for oil replacement, but also it gives a signal of your equipment condition, which component is wearing. For example, if you find a lot of silicon Si in this in your oil analysis, then it is indicating that there is a dust or sand ingress into your gearbox or your equipment. If your iron particles are highly concentrated, then it is indicating that some of the gear parts are wearing out. So it gives an indication, so you can plan for some maintenance. Then if you come on this side, wear measurement. So like original thickness, whenever you install any equipment, you have got a original thickness. You need to record that first. You can get it from the drawings as well, or you can physically measure it as soon as you have the equipment as new. Then after 6 months, after 1 year, or after every month, you make a maintenance downtime day and then you measure it. Then you will come to know the trending, how many grams we are losing it. Then you can predict, okay, if I am losing it at this rate, maybe in a year and a half, I may have to replace the liner. Something like that you can predict. Then if you come here, motor diagnostics, there are some sensors and tools available to also monitor the condition of the motors. So we can measure the certain parameters, the current amperes as across the three phases. Then also it gives, if there is a difference between each of the phases, then you can also infer something from that. Acoustic is used for leakage detection, especially in hydraulic systems. Then here we have got NDT testing, non-destructive testing, ultrasonic or magnetic particle or dye penetrant test. These are all the tests we can use to find out if there is any inherent defects or porosity within the steel components. Thermography, yes, we can use it to know the high temperature processes which is happening during the plant is in operation. Here comes the mobile maintenance. There are certain apps are available, mobile apps. So it is connected to your maintenance system. So if the company is subscribing to that app and then connect to the mobile, connect to the maintenance system software you have in the industry, then you can take your mobile phone or tablet when you are in the industry, and then you can punch in directly the feedback. It gets updated. So all of this are condition-based maintenance tools available in today's scenario. I'm not suggesting that all of this you should employ in every equipment. Every equipment has a peculiar function, and it has got a different kind of failure modes. So based on that, we choose the right tool and use that tool for that equipment. I have summarized here about what are the typical techniques we use in generally, and what is the purpose and what criteria we measure. Like I said, vibration measurement technique, monitoring technique, we can use only for rotating equipment. If you have a static equipment, this of course will not help you much. So like gearboxes, motors, fans, we can use the vibration analytical tools. And you can also, it is used to check the misalignment of rotor, impellers, or broken gear teeth, defective bearings, all of this. So this vibration tools covers almost half of your 50% of the problem you have in any big industries. Oil analysis comes the next. Okay, so here also you take an analysis for wear and tear, and in transformers you can use dissolved gas content and other water content. You can check this. There are certain national accredited laboratories available worldwide in several places. In every cities almost we have this. So you can have a sample sent to them and get it. Most important is we take the sample from the same point every time, and then we ask the agency who is performing the analysis to give them the trending, so that we know what was the sample when it was tested 6 months back and what was now, so we can come to some conclusion. Individual test does not reveal much, so we need to have a trending or correlation with what was there before and now. Infrared thermography is mainly used in electrical systems, so we can see the real-time temperature escalations and odd bearing issues. So we can predict the condition of the temperature during the plant is operation. It's a non-intrusive type, so you can use it anytime. Non-destructive testing, I've already talked about. The ultrasonic testing is the one which is widely used for any maintenance function to find out the surface or subsurface cracks. And also to some extent, it can predict the wear also. Acoustic is only used in hydraulic systems to detect the leakages. And electrical mega tests, probably you all might be very well aware. This is to check the winding conditions. So this is all the tools available in the market to improve your maintenance utility techniques. So this is a small animation of this ultrasound testing, how it works. So you can see here, the waves are passed from here. If it passed through it, then you get a graph, full graph, then no crack. If you have a crack here, then the waves are repeated back from that. So it indicates that there is a crack. So here is a crack. And the last one is shorter because it's a back wall echo. So this is a very common tool available So you can use this for testing any kind of steel. Only thing you have to note is the temperature should be in ambient condition when you are testing any steel part. Otherwise, this will be misleading. So the transducers, the probes cannot work properly. So this is a standard tool available in the market. So any industries, if you have a maintenance department, they will have this tool, and then they can use this to check the cracks in steel components. So yeah, this is how it works. If you don't have a crack, then there is no the wave travels and then reflected from the back wall. And if there is a crack, it gets reflected from that crack. So you get a interpretation like this. So this is a very, very useful tool. You can use it for your maintenance needs. So when you have a stoppage, then if you have, for example, a gearbox shaft or any fan shaft, you can use this to check for any cracks or any inherent crack. If you have a small crack inside, still the fan may be or the gearbox may be operating. But one fine morning, the gearbox will fail. The shaft may break into two pieces or crack may extend. Then you cannot be able to operate the gearbox. So then we switch to reactive maintenance. If you don't predict the failure, then automatically the gearbox fails. Then it gives you a call and you stop the industry. Then you repair it. Then you are basically switching back to reactive maintenance, which is not at all recommended. So we use this kind of technology or tools and improve our maintenance system. This is about these infrared thermographic cameras. So we can see the red spot shows here there is probably some terminal loose connections, which is leading to this high temperature. So the action what we can do is we switch off, isolate the power supply, then ask the qualified electrical technician to check these terminal boxes for proper crimping and proper tightening. So this is the way we avoid the failures. So it all helps to improve your maintenance systems. So finally, we talked about reactive maintenance is not at all recommended, but there are other three, I said. So then you might have a question, which one to follow? So here is the answer for that. So a standard maintenance management system should be mix of all three. So you employ a preventive maintenance to a large scale, to 70% you use the preventive maintenance system with full scale, then predictive and proactive to certain extent. Why? Because is this kind of measurement tools, sensors cannot be used in all 100 equipments. If you have all of the equipment, you cannot use this. But preventive maintenance system, you can use for all. Either it is a static equipment, rotating equipment, heavily loaded, like slightly loaded. For all of this, you can utilize preventive maintenance system. Predictive maintenance system depends on the tools available and condition monitoring team, what you have in your industry, and access to this and expertise, what we have. So I would like to say you mix all these three, then you can aim for achieving a maintenance excellence in your plan. Now we jump to talking about organization. So when we talk about the maintenance organization, any plant should have a maintenance manager, qualified maintenance manager. Why I put the slide here is, first we saw about three different functions: inspection, planning, and execution. So similarly, you should have these three different functions in your team. Otherwise, this will not work out effectively. So if you have a planners, if you have an electrical planner, mechanical planner, based on that process, if you should have a process engineer also. So there should be a planning team, and also we should have a team to execute the job. So this team here will work on the field to do the real replacement of the spare part. Okay. And then this team will plan the activity. Means they plan the resources, they plan when it will be done, and also they arrange for spare parts. And this team will go to the site and do the inspection and then they communicate with the planning team when what is the current condition of the equipment with respect to the original design or as per the drawings, and then what was the deviation. So they will predict this. This inspection team will give a feedback to this planner to plan the job, and this team will execute, and then they will give a feedback. So this we call as a reliability or improvement engineering function. And this team is the execution function, basically the site engineers, and this is a planning function. So all of them are under a maintenance manager. If you have this setup, then definitely the system what we talk about, it works well. So how this organization, what are all the factors which led to this development of this organization? Like we said, we improving the efficiency of the people. So we focus on these three functions: inspection, planning, and execution. Moving from the manual management, that's what I said. The Excel sheet management was very old. So now we use SAP or Maximo. So this kind of computer-based maintenance management systems, which will reduce a lot of your paperwork, and directly you get a work order generated on the system. You execute the task. Mostly it is done in a very systematic way. Then it saves a lot of time. You can focus it for your value-added activities rather than sitting and filling out the sheets. And maintenance cost management. Mainly cost management means it is every management would like to have a reduction in cost. So we move from a pure reactive to a predictive or proactive mix of this approach. Then our overall target here is to have a overall maintenance cost should be lower. So when we talk about the maintenance costs, we have got three costs: the maintenance team's cost, contractors cost, and spare parts cost. All the three are considered as a maintenance cost spending. Then reliability management, increasing the equipment life cycle. When you talk about lifetime, there are several lifetimes are talked about. One is the design lifetime. Another is the what do you call the guaranteed lifetime. The third one is actual lifetime. Design lifetime is like when the designer designs the equipment, piece of equipment, he considers, okay, this works for about 20 years, 15 years, or 20 years. Guaranteed lifetime is supplier is when once equipment manufacturer is selling the equipment to somebody else, he guarantees only for a certain period, say about 5 years or 3 years or 8 years. You don't guarantee the entire design lifetime. Why? Because if you maintain the equipment properly, then only you reach the design lifetime. So the supplier would never guarantee, provide a guarantee for a full design lifetime. That's the reason. So maintenance plays a vital role here. Then actual lifetime is what you get actually. So actual lifetime should be at least not less than 80% of your design lifetime. So how to reach that level? Only by doing a proper maintenance. So how to improve these practices? RCFA, root cause failure analysis, 5 why analysis. You keep asking why until you drill down to the bottom of the problem. So all this is about reliability engineering. So what is the organization's roles and responsibilities? We develop the preventive maintenance plan. That's the Excel sheet which I have shown before. I have shown example just for only for one equipment, a small equipment, ID fan. But for example, if you are in an industry where you have got about 600, 500, 600 equipment, you have to plan for all that. So the Excel sheet task would not work nowadays. So that's why we move to computerized management systems. So where we can punch all the data there, then you get all this checklist. And then based on this week, if you run the date, for example, today is 7th. So say your week starts from Monday. So 3rd February to 7th February, what are all the tasks? I have it. So if you go into the computer system and then check that, you will get all the activities, what you need to do from this Monday until Friday. So you do that, and then over the weekend, you punch all the feedback. Then automatically the next week task starts from next Monday. So, and then lubrication plan. When we had within our industry as well, we analyzed the failures for 10 years. We found most of the mechanical equipment failures, I would say about more than 30% are related to lubrication failures. So many times the lubrication has played a vital role. So the lubrication plan is very important to have the equipment healthy condition. Then we have this systematic implementation of condition monitoring techniques. That's what we see. We have seen just before about the NDTs, vibration analysis, thermographic tools, all of this. Planning function. These are all about inspection, then planning. Okay, after we inspect the equipment, we got certain idea when the equipment condition. Then we have the planning. What is our weekly and daily, what we do, and then we have the detailed methodology. Then coordinate the maintenance, shutdown planning, and manage it. So FMEA and root cause, I have got a different slide. We will go to that later. Standard maintenance procedure. This is to develop based on your own experience or with the OEM support. You can develop this to improve the maintenance practices. So it is monthly meetings. Maintenance manager or anybody would run the monthly meeting to monitor this monthly, what you call maintenance performance index, how it is performing, and decide the actions accordingly. Budgeting is key. If you have sufficient budget, then yeah, you can plan, you can execute your maintenance as planned. Otherwise, you will have a problem. So always it is suggested you make a 3 years capital expenditure plan so that you are provided with sufficient fund to execute the task. So this is a screenshot what we get to know the workflow. So once the work order is printed, the team leader, the planner allocates the work order, and then he scans the work order. When the execution team completes the work order, if it is yes, then it goes to here. It is enrolled in the system. Here we have a history. Using the advantage of the CMMS is, for example, if you are doing different maintenance at different times in different equipment. So once you want to have a maintenance history of any equipment, it is easy to extract, drill down from if you are using a computerized system. Then the team leader return to work order to the planner, and the planner makes a technical complete. So if it is not done, then these are all the tabs for replanning the work or postponing the plan. Many times you get a work order to do the job, but due to some reasons, you cannot be able to do. If you don't have resources, or if the spare parts are not available, or there are some other reasons which could delay. So then you have to go with the other part. But if you go with any CMMS system, the loop is closed. Until then, you cannot close the work order in the system, so it remains open. Now we talk about root cause failure analysis. RCFA is a very, very powerful tool. Why? Because it is a step-by-step method. For example, if you have a breakdown, some breakdowns we have seen the photos which I have shown. So that is all the ultimate result, the failure. But why it has failed? Then there are progress of actions which are leading to this failure. So you sit as a team. RCFAs are never done by alone. So you sit as a team of people, maybe process engineer, maintenance engineer, mechanical, electrical engineer, all of them, who is responsible for that area, for that equipment or that machinery. And then sit together, and then you have the chronology of the different happenings that took place before the failure. Then you analyze, you discuss, you refer the drawings, data, specifications, and different measurement readings, what you have, or the parameters. Then you come to a conclusion. Okay, this was the root cause which has led to this failure finally. Then how to eliminate the root cause? You make some action plan and implement it. That's why RCFA, when you do a successful RCFA, the same kind of failure should not repeat again. If you have a similar failure repeating again and again, that means either you don't have RCFA in your organization, or your RCFA is not effective. You may have to do it differently. So this is about that. Just now what I said is the same. So you first use all the evidences, and then you construct a fault tree. with all the progressive actions. Then it is a step-by-step process. Then you finally come to the sequence of process. Then you make a conclusion. Okay, this was the problem. For example, if a shaft is sheared, then you have decided that, okay, somebody has used unknowingly a welding with a high temperature, heat affected zone has caused a crack in the welding. So what could be the action you take? Then you say that you educate your team not to do any kind of welding. You have to go with a different kind of repair solution, or to replace the shaft at the moment if you don't have a choice. So you make list down short term, long term, all the corrective actions which you propose. Then you assign somebody to execute that task and then close the case. So this is how the RCFA works. So if you have a breakdown, you do a proper RCFA, then you implement the action, then make sure that same problem does not repeat for at least next 5 years. That means then your RCFA process is successful. So the conclusion is RCFA is to prevent the reoccurrence of failure. Sometimes it may happen that the breakdown is happening due to design problem. So then in that case, a redesign is necessary. But as I said before, most of the time, if you analyze any breakdown, more than 70% of the cases are relating to lack of adequate maintenance or lubrication or timely replacement of parts or overloading, and not a design problem. But it is a general thinking is that when any equipment fails, everybody jump to look at the design parameters and say the equipment is under designed or not designed for this particular application. But in practical, it doesn't happen like that. Statistic doesn't at least say that. FMEA is slightly different. FMEA is failure modes and effect analysis. We do the FMEA before even the stoppage occurs. When you get a new equipment or machinery, then you study the functioning of that equipment or a system. Then you list down. You imagine, by imagination, you think what are all the failure could happen. If there is a gearbox, you can think the gear tooth surface may crack, the bearings may fail, or the gearbox seal may be broken. So you assume certain failure modes, then you quantify the effects. If these failures happen, what will happen? Then you list down the causes. So there is a detailed working sheet available how to make this risk priority index. Then you plan also some actions, how to prevent these failures from happening. Then you implement that into your preventive maintenance system. So the FMEA we do before the failure. So here is the conclusion. FMEA is prevention. RCFA is a reaction. RCFA we do after the failure to prevent the reoccurrence of the failure. But FMEA is a very advanced one. You need a lot of expertise to do that. When you are purchasing a new machinery, you may not be having so much knowledge at that point of time. So FMEA is a challenging task to do, I would say. And because you need to anticipate the potential failures, even if you miss one of it, then you will still have a failure. That's why we have RCFA. So these both are two powerful tools which will definitely help a lot to improve your maintenance systems. So now at the last part, okay. So at the last, we have this technological advancement and digitalization in every area, and it does not leave maintenance systems as well. So if you see here, we have this production plant area where we have got several sensors available, which are mounted directly on the equipment or the machinery. It collects real-time data, 24/7. Data is transmitted. Then on remote people, there are some algorithms, models developed to analyze the behavior, trending of the data. If the trending of the data is uniform, these algorithms just keep quiet. If there is any abnormal finding, then they send the signals. It is analyzed by an expert. Then it is transformed into a work order to the computerized system. Then your plant team engineer go and repair or do the service. So this can be anywhere. You set up the sensor and then you transport the data via data cloud using secure internet connections. So the server can be in Germany, it can be in US, or it can be in Singapore, it can be in anywhere. The analytical team can also sit anywhere. Your plant can be in any remote area. Still, the expert can support via these analytical models and then give you inference on how your equipment is functioning. In fact, we are employing mostly these tools in the last 5 years for our plants. So this you get a trending also. Here, if you see a blue trend, it says about the input shaft bearing condition indicator. You see it is going up over a period of time, say in 6 months' time, the trend was going up. So it is indicating that the bearing is deteriorating. Maybe the bearing has got fittings, or the cages are slightly broken, or it is wearing out. So after the bearing was exchanged with the new one, you see this as come down drastically. The amplitude has come down drastically. So you can visualize this kind of data on your screen. Then you can also predict the failure. So this type of systems are available. So advanced predictive maintenance system, how it works. For example, you have a pump or any motor system. You can use this type of sensors. These are wireless sensors. So it can transmit using Bluetooth to certain area where we provide this data collectors in every 50 meters or 100 meters. Then this has got a internet connection. Then it transmits the data through cloud to different data centers where the models, algorithms are deployed to analyze the trending. 24/7, it is monitored by algorithm. Abnormal trendings are reported to expert. Then expert analyzes the abnormal signals. If it is a false signal, he ignore it. If it is really abnormality, then he alerts the user. This is the user who is having the screen to visualize that feedback, what you are getting from this analytical experts. Then you take action. Either you change the bearing, change the gearbox, or do some maintenance action. You put your feedback here right away. Then this whole of this team knows also what you did. The history is updated as well, maintenance history. So this is a much more advanced system, but many industries have already upgraded to this kind of maintenance systems. So in conclusion, I would say digitalization has transformed plant maintenance practice. We started with reactive maintenance, which is never ever recommended. Then time-based, fix it before it fails, preventive. It has got some advantages, many advantages, some disadvantages too. Then predictive, it is condition-based. We use certain condition monitoring tools to find out the condition. Then prescriptive is data-driven. The last few slides which I have shown, the data interpretation will give you a signal when it is going to fail. So you can avoid the fix, you can prevent the failure, and you can have a better optimization of your asset utilization. I think that's all. Thank you very much. So now it's open for questions.
Thank you, IYAPPAN. It's a very highly informative and eye-opener session. You can say that because our students are new to maintenance concepts. They just know what are the types of maintenance: routine maintenance, preventive maintenance, scheduled maintenance, all those things. But you have given a very exhaustive information. Thank you on behalf of Murugappa already. Chandru or any faculty, if there is any question from students, you kindly unmute your mic and you can give it to the students. They can ask the questions. I already told you that students are not allowed to bring their mobile, so that's why we organize this meeting and staffs are accompanying them.
Okay, no problem. Yeah.
They have any question, they will ask from staff's mobile phone.
Right. Okay.
Chandru, if any students are looking for any clarification, kindly unmute your.
So one student asked a question.
சந்திரு அந்த ஸ்பீக்கர் இதா இருக்கிறதால எக்கோ ஆகுதுன்னு நினைக்கிறேன். ஸ்பீக்கர் வால்யூம் கொஞ்சம் கம்மி பண்ணிடுங்க.
Sir, we would like to know if you can explain it based on our scale of work, sir. We do maintenance works in the college, sir. We would like to have more examples on mechanical based machines, sir, like lathe.
Okay. Okay, right. See, if you have certain tools like lathe tools or others also, you have to list out which are like you will be having a motor there. You will have some jaw clutch as well as you have some other components which are bound for wear and tear. So you have to categorize the motor electrically. Like I said, you can use some techniques like measuring to check the insulation and other things frequently, once in a month or so. And for like other areas where you have got a wear and tear, you can keep some thickness measurements. So for every equipment, you have to first find out what are all the parameters you would like to measure and monitor. So then you define your maintenance practice.
Sir, what is mean by preventive maintenance?
Okay. See, the first one is what we talked about is reactive maintenance. For example, if you have equipment, you keep on running. A simple equipment is a fan. You keep on running the fan, ID fan, until it fails. You don't do any repair or any kind of greasing, or you don't even go and check. So once it fails, then you go and find out what was broken, then you replace it. So that is reactive maintenance. So preventive maintenance is every month or every week, you go and stop the machine for say 1 hour or 30 minutes. After it cooled down, you go and check certain items. You check the bearing, you open the cover, you check the bearing or coupling. Then you will know the condition is good or bad. So you try to prevent the failure. So that's why it is called preventive maintenance.
Dear students, if you have any doubt, you can ask in Tamil also. Ayyappan sir can explain Tamil also. பசங்க கொஞ்சம் இங்கிலீஷ்ல क्वेश्चंस ரைஸ் பண்றது கூட யோசிச்சிட்டு இருப்பாங்க. You can ask in Tamil also. No issues.
Yeah, okay.
Sir, I have one doubt, sir. So, what is the difference between scheduled maintenance and breakdown maintenance, sir? And I need some more examples.
Okay. Scheduled maintenance is same as preventive maintenance. Only the words are different. Okay. Scheduled maintenance means we schedule some task monthly, yearly, quarterly, like that. Breakdown maintenance is same as reactive maintenance. Only the wordings are different. It is the same. Reactive maintenance means after the breakdown, only we do something. We don't do it when the equipment is already working. We don't plan to stop and check. So maintenance is about inspection. If you don't do the inspection, then it is called the breakdown maintenance.
Thank you, sir.
Welcome.
So, corrective maintenance means what, sir?
Corrective maintenance is like you have got a breakdown, then you replace some spare part, then you correct the equipment back to original state. This is called corrective maintenance. But in corrective maintenance, there are two categories of maintenance we do. One is short term, which is called a corrective, and long term, which is called preventive. That means you have a breakdown, you replace some part, but you know that the repair what you are doing is temporary, not final. So it will work for certain time, maybe 1 or 2 days or 1 month. Again, the same kind of failure or breakdown will happen. Then you will do a bigger repair or replace the machine or replace the spare part or a big component. That is a corrective action. There are two. This is another type of corrective action.
Sir,
Yeah.
Sir, what is mean by total productive maintenance, sir?
Say again, please.
Total productive maintenance.
Okay. TPM. Okay. Total productive maintenance is we consider the whole industry or the plant, and then how we make the maintenance management is based on our production target. For example, if a car manufacturing unit has to produce, say, 50,000 units of car in a year, then every department, everything has to target focusing on that volume of production. So that is called total productive maintenance. So we design our maintenance strategy suiting to that, not to our equipment directly defined by the equipment categories.
Sir, what is the difference between scheduled maintenance and routine maintenance? Give some example.
Scheduled maintenance and routine maintenance are same. Actually, the wording is different, I would say again. Example, if you want, for example, if you want like to say bearing which needs a lubrication every 4 weeks. So every 4 weeks, somebody go with a grease gun and do the greasing. Every month, 5 strokes of grease he applied. So this is called a scheduled maintenance. You apply the lubrication every month to the same equipment, 4 strokes or some 10 grams you apply. So this is scheduled maintenance. Routine maintenance also is same, but it can be like inspection. You just inspect it and come back every time, or you do some greasing, oiling, or you do some other task, maintenance task. That's why we call it as a routine maintenance. So routine and scheduled is both are same, I would say. Schedule may be like you schedule it every month, every week, every year, like that. Routine means basically every shift or every day. For closer frequencies, we say routine. For larger frequency, we say schedule. But both means the same kind of task.
Hello, sir.
Yeah. Yes,
Sir, what is condition-based maintenance, sir?
Condition-based maintenance, I will try to give an example. See, for example, if you are having a car with a tire, okay. So condition-based maintenance means every car tire has some indicator to indicate the worn-out condition. So when you have to replace your tire, okay, this is condition-based maintenance. So based on the thread, whatever is there on your tire, if it gets decreased to certain extent, then when it reaches the minimum or almost no, then the tire becomes flat, then you replace it. This is the condition-based. But some suppliers, some car manufacturers say every 5,000 kilometers you change the tire. This is time-based maintenance. This is the difference. Every 5,000 kilometers, whether the condition is good or bad, you just change the tire. That is time-based maintenance. Hope you got it, eh?
Hello.
Yeah. Are there? Yeah. Yes, please.
Yes. Is there any more questions, students? Chandra sir, any questions?
No, sir. No, sir. That's all.
Okay.
No, sir.
IYAPPAN sir, I have a question.
Yeah. Please go ahead.
என்னடா என்னுடைய ஃப்ரெண்ட் ஒருத்தர் இருக்கா, அவன் என்ன பண்ணுவான்னா அவன் எக்யூப்மெண்ட்ல ஒரு எக்ஸாம்பிள் ஒரு வண்டி வச்சிருக்கிறான்னு வச்சுங்களேன், வண்டியில டயர் பஞ்சர் ஆச்சுன்னா பஞ்சர் ஓட்ட மாட்டான், டயரை ரீப்ளேஸ் பண்ணுவான். ஐ மீன் டியூப் ரீப்ளேஸ் பண்ணுவான். ஒரு எக்ஸாம்பிள் சொல்றேன். அது மாதிரி ஒரு எக்யூப்மெண்ட் வந்து ஒரு பிரேக் டவுனோ இல்ல ஏதோ ஒன்று ஆச்சுன்னா அதை சர்வீஸ் பண்ணி யூஸ் பண்ண முடியும். அதுதான் மெயின்டெனன்ஸ் உடைய இதுவே இல்லைங்களா, சர்வீஸ் பண்ணி யூஸ் பண்ணலாம். பட் அவன் ஏதாவது ஒரு இஷ்யூ ஒரு ப்ராப்ளம் ஆச்சுன்னா ரீப்ளேஸ், அது பதிலா இன்னொன்னு வாங்கி வைக்கிறது. அது ஒரு கரெக்டான இதுவா? அது என்ன
ஆக்சுவலா வந்து அது
மாத்திட்டா ப்ராப்ளம் வராது, அடுத்து திரும்ப ரொம்ப கம்ஃபர்டபுளா போகலாம் அப்படிங்கிற மாதிரி ஒரு இதுல இருக்காங்க. அது பத்தி என்ன நினைக்கிறீங்க நீங்க?
அதுதான் ஆக்சுவலா அந்த கம்ஃபர்ட் ஜோன்ன்றது நீங்க சொன்னீங்களா, அதுலயே ஆன்சர் இருக்கு. மெயின்டெனன்ஸ்ல வந்து அது ஒரு டைப். அது எப்படின்னா when it comes to இண்டஸ்ட்ரியில வந்து பாக்குறப்போ இஃப் யுவர் ஃபியூச்சர்ல எப்போவாவது ஹை டிமாண்ட் சீசன்ல அந்த மாதிரி ஒரு பிரேக் டவுனை நம்மளால ஏத்துக்க முடியாது அப்படின்னா, இப்போ மார்க்கெட் வந்து பீக்ல இருக்கிறப்ப ப்ராப்ளம் ஆயிரும் அப்படின்னா அந்த மெத்தட் ஓகே, ரீப்ளேஸ் பண்ணிடுறது பெட்டர். பட் இதே இது வந்து நமக்கு வந்து இப்போ வேர் ஹவுஸ்ல இன்வென்ட்ரி இருக்கு, ஸ்டோரேஜ் இருக்கு, இந்த மாதிரி ப்ராப்ளம் வந்தாலும் 1 or 2 days பிரேக் டவுன் தான். ஸோ இட் வில் நாட் டைரக்ட்லி இம்பாக்ட் த பிஸ்னஸ் அப்படின்றப்ப தென் இந்த மாதிரி ரிப்பேர் அண்ட் சர்வீசிங்க்கு போறது தான் பெட்டர். ஸோ இதை தான் நம்ம வந்து மெயின்டெனன்ஸ் ஆப்டிமைசேஷன் சொல்றது. ஸோ போத் ஆர் அக்செப்டபிள், போத் ரெண்டையுமே வந்து நம்ம தப்புன்னு சொல்ல முடியாது. பட் அது நம்ம எந்த மாதிரி சுச்சுவேஷன்லன்றதை நம்ம வி ஹவ் டு டிசைட். நம்ம ரீப்ளேஸ் பண்ணாம வந்து பேட்ச் பண்ணி ரிப்பேர் பண்ணி எதாவது பண்ணி ஓட்டிட்டு இருக்கிறோம். இப்போ ஆல் ஆஃப் சடன் வந்து ஒரு ஹெவியா ஒரு ஆர்டர் வந்திருக்கு, அப்போன்னு பார்த்தா அந்த ரிப்பேர் நம்ம பண்ண ரிப்பேர் மறுபடியும் பிச்சுக்கிடுச்சுன்னு வச்சுக்கோங்க. ஸோ தென் வி ஹவ் டு ஆன்சர் சம்படி வாட் ஹேப்பன், வாட் வென்ட் ராங் அந்த மாதிரி. அதனால ஸோ வி டோன்ட் சே போத் ஆர் நாட் ஓகேன்னு சொல்ல மாட்டோம், அது சிச்சுவேஷனல்.
Okay. One more we have come across a topic called the chance tools. Chance tool. Some ஒரு காம்பனன்ட் பிரேக் ஆயிடுச்சு, ஒரு பர்டிகுலர் பார்ட் அதை ரீப்ளேஸ் பண்ணணும், பட் அந்த பார்ட் இப்போ இமிடியேட்டா கிடைக்காது. சோ அதுக்கு அந்த இடத்துல டெம்பரவரியா வேற ஏதோ ஒரு பொருளை வச்சு அட்ஜஸ்ட் பண்ணி அந்த எக்யூப்மெண்ட்டை ரன் பண்றது, அது அட்வைசபிள். அந்த மாதிரி ஒரு பட் ஜெனரலா வந்து சான்ஸ் டூல் யூஸ் பண்ணக்கூடாதுன்னு ஒரு அட்வைஸ் சொல்றாங்க.
ஆமா, ஆக்சுவலா எக்யூப்மெண்ட் வந்து இப்ப புதுசா பர்ச்சேஸ் பண்ணிருக்கிறோம், வாரண்டி கண்டிஷன்ஸ்ல இருக்கு அப்படின்றப்ப அப்ப இந்த மாதிரி பண்றது கண்டிப்பா அவாய்ட் பண்ணிடணும். ஸோ எக்யூப்மெண்ட் வாரண்டி எல்லாம் முடிஞ்சிருச்சு, ஸோ இட் இஸ் டோட்டலி அண்டர் அவர் கண்ட்ரோல், நம்மளால அன்அவாய்டபிள் சுச்சுவேஷன் அப்படின்னா வித்தவுட் compromising the safety standards then we can still do it. Safety of equipment as well as safety of human being and the mary modification, yes, still we can do.
Okay, thank you very much. Sir Chandru sir wind up பண்ணிக்கலாமா? Hello Chandru sir, if there is no more question நம்ம wind up பண்ணிக்கலாம் sir. Thanks சொல்லிட்டு. Hello. Okay, sir. I think there is no more question. Thank you, Mr. Ayyappan, for readily accept our invitation and sparing your valuable time. On behalf of Polytechnic and on behalf of the department and on behalf of all the participants of our department, I extend our sincere thanks to you. Thank you very much. And we expect you some sort of this kind of seminars in the future also. Thank you.
Okay, sure. Whenever, it's possible, I will definitely try to support. No worries. So thank you very much also and giving me this opportunity and inviting me to give this lecture. Thanks a lot. So I wish, at least I was able to impact little bit on this maintenance system. So let us see. Okay. Thank you very much. Okay.
Thank you. Thank you.